let's explore what is E. This is also called pronounced Euler. Okay, so Euler's number. So this is a irrational number, just like pi. It doesn't have a definite value. It goes on forever. Okay, so E goes on forever, and it's about 2.7, and it just keeps on going. Okay, and it was yeah. So let's learn like what does this 2.7 even mean? So imagine we have a bank, right? And we have to open a bank account. And the bank, as soon as we walk in, they say you are our lucky 100th customer. Every 100 customers, we give you a special offer. What we're gonna do, every dollar they put into our bank, we're buy like for every amount you invest. At the end of the year, you can get 100% of your money back. Okay? For example, if I put in $10, at the end of the year, there will not be $10 anymore. There will be $20. Okay? So just for 1 year, they said they're gonna do that. That's a very good deal. But they also gave some conditions. They said that you don't have to take the 100% back right away. So for example, you can take it back 5% one day, then maybe the next day you can take 2%, then you can take maybe 10%, but in the end you can only take up to 100% of your money back. Okay? So let's look at 3 examples so we understand how this bank works, because I was confused when they told me this offer. So they said, okay, let's look at 3 examples and then you can decide how you want to collect your money. So let's say Joe. You know, Joe, he's a very irresponsible guy. But he doesn't really like look at his bank account that much. So what he did, he put $1 in when he got the offer, and then at the end of the year, he never collected any money. And so the bank called him, hey Joe, you never collect your money, so we're just gonna double it, okay? So what they did, they just gave back 100% at the end of the year. So what is 100% of 1? It's 1, right? So we're gonna add 100% of what he put in. He only put in $1 also. So he put in $1. And he gets back 100% at the end of the year, meaning he'll have $2. Okay? That was Joe's case. Next, I looked at Bob's case. So Bob, what did Bob do? Bob also only put $1. I don't know why they're only putting $1. So, but except he wanted to go to summer vacation. So he took 50% in the summer, and then he took the other 50% during the winter or something. So if you took 50%, so basically he took 50% every 6 months. He still only took 1 year, and he only still took a total of 100%. Except he broke it up to 50% and 50%. He didn't take 100% at once. So this is how Bob's money is account gonna look like. So he took plus 50%. So if you take plus 50%, what is 50% of 1? 50 cents, right? 50% of $1 is 50 cents. So he's gonna add that onto his total amount. So that becomes what? $1.50. That was for summer vacation. Now, when it's winter, by the end of the year, you have to collect the rest of the 100%. So what's left over? Another 50%. What is 50% of $1.50? What is half of 150? 75 cents, right? So add 75 to this, you get $2.25. Wow. I already see that they both took 100% in total, but since Bob took 50 and 50, his total amount of money is higher than Joe's. Okay, I got pretty excited about this. Wow, so they're not all the same. So there is some strategy going on. Okay, now I have to analyze the case more. So like, bank, show me all the cases. And so they showed me only one more case. And they showed me the case of Emily. So what did Emily do? She went to vacation every 3 months. So basically every season, she decided to go to a vacation. Oh, how did she do it? So she had $1. And then, if you're gonna, she took it equally each time. So she took 25%, plus 25%. If we, what's 25% of $1? 25 cents, right? So if we add 25 cents to $1, what do we get? Well, $1.25. What if we add another 25%? Okay, so 25% of $1.25. Don't worry, I did on the calculator because I was very curious, and it's $1.56. Okay? Remember, she's gonna do this 4 times so that she uses. So far she's used 50%. 25 and 25. She's gonna do it all the way up to 100%. So she's gonna do it again. Now plus 25%. So what's 25% of $1.56? Added to $1.56 is $1.95. Okay, 75% done. Now she's just gonna do it one more time. Collect her last 100% at the end, 25% at the end of the year, and turns out, you know what she got? $2.44. Okay, so I see the pattern here. As we keep on increasing the amount of times that we're going to collect, it doesn't matter though, even though we are going to only collect 100%. Let's say I collected 1% every time. 1%, 1%, right? Or let's say I collected every day. Then it's going to be like, then it's going to be so many times, right? So if the more often times I collect, even though it's going to be equal to 100%, I see that through these 3 cases, the amount was increasing each time. Okay, so how can we rewrite these? Because I wanna like write a function for this kind of trend, so then I can truly understand how this system works. Because these are kind of random values. 225, 244. Okay, so the first thing we're gonna do is we're gonna see plus 25%. What is another way to write plus 25%? Another way to write plus 25% is just writing times 1.25, right? Times 1.25. So we take this, we multiply it times 1.25, and we get this. So we can write that same thing for here. For here, we take it and we multiply times 1.25. So we're going to multiply times 1.25. Again, we're just taking this guy, the amount we have, multiplying by 1.25, and we get this. Okay, do it again, plus 25% again, same exact thing. It's just multiplying by 1.25. And that will be the same, so 1.25. Okay, I didn't change anything. We're just going to rewrite so we can truly understand it. What about here? What did I really do? So when I say plus 50%, we know, what is this? This is just the same thing as times 1.5, right? Times 1.5. $1 times 1.5 is $1.50. $1.50 times 1.5 is $2.25. Same thing here. $1 times 2 is $2. So what is another way we can write $1, $2, 1.25 times, instead of writing 1.25, I'm going to write it like this. 1 plus 1/4. By algebra, we know this is the same thing. Instead of writing times 1.25, I'm going to write times 1 plus 1/4, which is 1.25. Okay, this is literally the same thing, 1.25. I didn't change anything. Alright, same thing. What is 1 plus 1/4 is 1.25. So instead of writing 1.25, I just rewrote it. So I'm just going to rewrite it. I'm not changing anything, we're just rewriting it. And this will help us analyze what's really going on. So 1 plus 1/4, and then again it's times 1 plus 1/4, right? And this one is, what is this going to be? I'm going to rewrite 1.5 as 1 plus 1/2, right? I'm going to rewrite this one as 1 plus 1/2. And what are we going to write this one as? 1 plus 1/1. That's 2, right? Okay, so what do we notice about all of this? So here, how many times am I multiplying 1 plus 1/4? Let's count. 1 time, 2 time, 3 time, 4 time. Now, let's just make sure we can see. So 1, 2, 3, 4. And we know that makes sense because Emily, she took it 4 times a year, right? So we're just counting how many times she did it. So she did it like this. We can write 1 plus 1/4. You know, when you're multiplying the same number again and again, what can you use? You can use exponents. So we can just say to the 4th power, right? She did it 4 times. Okay? And we started off with 1. So 1 times 1 plus 1/4 to the 4th. So she starts off with 1, and then she multiplies this 4 times, right? Let's write that same thing. So what did Bob start with? Bob started with 1, and then he multiplied his amount by 1 plus 1/2. 1 plus 1/2. How many times did he do this? He did this 2 times. 1, 2. You remember? He went to summer vacation. So 2 times. Okay, we got like a equation for Emily, and we got an equation for Bob. How about Joe? He started off with also 1. So we're gonna write 1 times, well, he multiplies it by 1 plus 1/1. How many times does that? Just 1. Okay. Now we're gonna forget about these stories. I don't really care about their names. I don't really care what happened. I have the equation. That's the most important thing. I have the equations, so I know really what went on. Let's just analyze all these equations. Hopefully we can see what it really means by this. So this was Joe, this was Bob, and this is Emily. So how can we write this as a function? F of x equals, okay, so I see in all of them we have 1 times something, and then all of them have a parenthesis, and all of them have a 1 plus. And then all of them have a numerator of 1, but it seems, what is the thing that's changing? The denominator is changing. The denominator and the exponent is different for all of them. So I'm going to leave that as x, because it's always changing. I'm going to leave the exponent as x. So that's basically our function. Because look, if we say f of 1, we plug in 1 here and here, and that's exactly what our function will say. If we say f of 2, then when we plug in, then this number will be 2 and this number will be 2, just like the function says. F of 4, no different. 4 and 4. So it happens to be, as we keep on increasing x, right? So we have, now we know what our x's are, and we know how this function came. So it's 1 plus, like this. So we have this guy. We're just going to simplify it a little bit more. We know that when we multiply 1 by anything, it doesn't change it. Right? We have 1,000 times 1. We don't have to write the 1, it's just 1,000. We have 99999, negative 999 times 1. It just stays the same. We don't have to write 1. So I just got rid of the 1. So it happens to be this is our function. F of x is equal to 1 plus 1 over x to the x. And this is actually how we describe growth. So as x gets bigger and bigger and bigger, it approaches that number 2.7. And it keeps on going on, going on, going on, going on. So as we keep on collecting money, the number will get closer and closer to 2.7. So in the beginning we collected $2. The second, then we collected $2.25. Then we collected $2.40, right? $2.44. And it keeps on going, going, going as x becomes 100, as x becomes 1,000, as x becomes 10,000, 100,000, right? You will get closer. This will keep on going on, and it will be 2.7, and then 1, and then 8, and then keep on going on forever, right? So that we, instead of writing this big number, we just use the letter E. That's Euler's number. Hope this helps.